Hi. So it's a question of CAT 2020 slot 1. How many distinct positive integer valued solutions exist to the equation? Now, if you look at this left hand side of the term, it's an exponential form where both the forms, base and the power, both are quadratic equation. It seems like a very difficult question. You must have seen this question in our class sheet also. Now, two equations are there. One is in the base and the other in the power, and the value must be equal to 1. Okay, let's look at the left hand side and right hand side carefully. The right hand side is 1. When do we say that a term raised to the power anything is always equal to 1? If it's like in a to the power 0, I can say that a to the power 0 is always what? 1. That means whatever may be the number, but if the power is 0, the whole term will become what? 1. So this is one of the cases, case number 1. What else? What if the base becomes 1? 1 to the power anything is always equal to what? 1. So the second case will be what? X square minus 7x plus 11 is equal to 0. So you get two equations here. X square minus 13x plus 42 is equal to 0. And the other one was x square minus 7x plus 11 is equal to 0. When you solve this, you get two answers. X is equal to 6 and 7. So we get two values from here. X square minus 7x plus 11, second case. Now, x square minus 7x plus 11. What did I say? First one, the power has to be 0. The second case is what? The base has to be what? 1. So effectively, this becomes x square minus 7x plus 10 equal to 0. When you solve this equation, you get again two roots, 2 and 5. So effectively, we got four answers here. 4 is there in the option. Yes, sir. Are we missing something here? Think about that. Are we missing something here? Any other case when the left hand side will become equal to 1? Yes. What if I say that this base equal to minus 1 raised to the power an even number? That is also equal to 1. There is one more case, third one, when the base becomes minus 1. But you'll have to ensure that the power is even. So let's assume that my base, which is x squared minus 7x plus 11 is equal to minus 1. Yes or no? So what do we get here? When you put minus 1, you get x squared minus 7x plus 10 is equal to 0. Now, x squared minus plus 10, sorry, it's plus 12. Now when you solve this equation, you get two roots here, 3 and 4. So you get 2 another. So effectively 2 plus 2 plus 2, your answer becomes 6. But before marking your answer as 6, you need to cross check that 3 and 4 will satisfy this or not. Because you need to ensure that if the base is minus 1, power has to be even. What's the power here? X squared minus 13x plus 42. You need to cross check that this is even for both these values of x or not. When you put x equal to 3, you get an even number here. Even when you put x equal to 4, you get even. That means both these values will satisfy the given condition. So effectively, how many integer valued solutions will pair? 2 plus 2 plus these two. So the answer becomes 6. Thank you.